Hello, this video we are in chapter 6 and we are in section 6.8, fitting exponential models to data. In this section we will build an exponential model for data and build a logarithmic model from data. Okay, so think back, we talked about linear regression back in chapter 4 where there was data that kind of trended towards a linear relationship. Well, we also have other types of regression. Today we're going to talk about exponential regression and logarithmic regression. So exponential regression is used to model situations in which growth begins slowly and then accelerates rapidly without bound, or where decay begins rapidly and then slows down to get closer and closer to zero. So in the TI-8384 calculator, you use this function or command in the calculator, expreg. I'll show you where to find that in a moment, to fit an exponential function to a set of data points. So if you'll remember back in when we talked about linear regression, we did the linreg function. So for this, we'll use the expreg function. This returns an equation of the form y equals a times b to the x power. A couple things to note: b has to be non-negative. It can't be negative. When b is greater than 0, we have exponential growth, and when b is between 0 and 1, we have exponential decay. So that kind of follows what we learned about exponential functions. So now, given a set of data, perform exponential regression using a graphing utility. So I have the steps here for doing this on the TI-83 or 84 calculator, but I also have steps for using Desmos. So we're going to do these steps for the TI-84 calculators, 83s as well if you have them. So the first thing you do is stat, edit, and enter the data. That's the first step. Okay, so we usually enter the data in L1 and L2, but you can enter it in other lists if you want to. Just keep track of where you put your X's and your Y's, okay, from the data. The next thing you're going to do is you don't actually have to do this. It's not required to write the equation, that is. It does help to look at the graph to make sure that everything's a good fit. So graph and observe a scatter plot of the data using the stat plot feature. So if you want to graph it on the TI-84 calculator, you hit the stat plot feature and turn that on, just like we did when we did the linear regressions. And then zoom 9, adjust the axis. Verify the data following an exponential pattern. Now to find the equation, so you can actually go from 1, and then if you just want the equation, you can skip to number 3. You find the equation by going to Stat, Calc, and choosing expreg, so the exponential regression. And then it will give you a and b, and you will fill in this formula here, y equals a b to the x. So you'll fill the a here and the b here. And then you're going to graph the model in the same window as the scatter plot to verify it's a good fit for the data. So that's one way to do it with the TI-84s. Now, many of us are using the Desmos calculator, and you'll remember we did linear regression using the Desmos calculator, and it was actually pretty easy. So this is equally just as easy. First, you're going to open up your Desmos, and in the first box, or above the first box, click the plus sign on the top left, and click on the table, so that a table will open up, and then you're going to enter your data. Then once you enter your data, there's a magnifying glass or a plus sign on the bottom left, but beneath that table, so under the table to the left. If you click on that, it will adjust your window so that you can see that scatter plot. Then in box 2, you're going to type in y1, the tilde symbol, a, b, carried to the x1. Now, just note that it's y1 and x1 if your data in your table is y1 and x1, but if you have multiple tables going on, in Desmos at the same time, you can those numbers will change. Like you might have x2 and y2 and x3 and y3 and so on and so forth. I'll show you that in a moment as well. And then use the values returned for A and B to record the model, just like we did with the other calculator. And then this one is easier than the TI-84s to verify that there's a good fit between the regression model and the scatter plot. So Desmos, as you know, is very visual because you can see the equation on one side of the screen and then you can see the graph on the other. All right, so let's look at an example. All right, so using exponential regression to fit models to data. In 2007, a university study was published investigating the crash risk of alcohol-impaired driving. Data from 2,871 crashes were used to measure the association of a person's blood alcohol level, BAC, with the risk of being in an accident. The table shows results from the study. The relative risk is a measure of how many times more likely a person is to crash. So, for example, a person with a BAC of 0.09, right here, is 3.54 more times likely, or I'm sorry, 3.54 times as likely to crash as a person who has not been drinking alcohol. So, very interesting table. Now, there was not enough room to list the whole table, so you notice your X's are here. This is one list of X's. And then your Y's are here and here. So if you're going to use the TI-84 calculator, let me clear this out. Go to Stat, Edit, and then I've got a lot of data already in here. And then if you look at L1 and L2, I've entered the data. Okay, so I'm going to put this back up on the screen. Pause the video. Okay, pause the video and enter your data into your TI-84 calculator. Okay, let me just go back to Desmos real quick as well. So if you want to put your data in Desmos, okay, so you click in your box. Now I know I have a lot of things in here because this is part of the lesson, so I don't have to type the numbers while I'm teaching. They're already in here, but you type or hit the plus sign at the top left and then hit table, and the table pops up, and then you put your data in. Okay, so back here, pause the video, enter your X's and your Y's in either calculator, and then when you're ready, unpause the video and we will go over how to find the regression equation. Okay, so let's look at what the questions are. So it says let X represent the blood alcohol level and let Y represent the corresponding relative risk. Use exponential regression to fit a model to these data. So I'm going to show you two ways to do this. First way is with the TI-84 calculator. So I've put the data into L1 and L2. So you hit Stat, go over to Calc, and you find EXPREG. So that's A on mine. EXPREG. So that's exponential regression. Now, depending on the type of calculator you have, you might need to, let's see. Let me see if I can pull up. Here's another version of the calculator. If you go to Stat, Calc, EXPREG. So on this calculator, it's 0. So for some of you guys, there may be prompts. So you would put L1 here, and in the X list, Y list would be L2. The frequency list I would just delete out, and then you can go to calculate. All right. So for this one, I'm going to do second 1, second 2. Because that is where my data is, L1, L2. And here we go. We have Y equals A, which is 0.5830, and B is 2.207 e to the 10th. Okay, so we'll write that down in a moment. But I want to show you how you can do the same thing on Desmos. So I know I have a lot of data in here. So my X1, Y1 I have right here in this first table that I've entered. And if you hit it, the little magnifying glass with a plus sign in it, if you click that, it was the bottom left, you'll see your scatter plot pop up. Now I'm going to add an expression. And oops, so right here, and I'm going to do Y1 and then the tilde mark, and then I'm going to put in A times B. You don't need the multiplication sign, you just do AB, and then the caret sign carried to the X1. And if and then, sorry, make sure you click the log mode. There's a little click for that. Click that, okay? I was a little confused for a second there. I'm like, wait, that's a different equation. But that's why you have to hit the log mode. Make sure you hit log mode. And so you can clearly see over here on the right, you can see that the regression model is a really good fit for that scatter plot. Okay, so 0.583. So I'm going to write that down. Y equals 0.583. It doesn't say how to round, so I'm just going to leave it 0.583 times B. All right, now B is a little bit crazy because it is 2.207202133 e to the 10th. So that means, so I'm just going to write down here 2.7. Let me go back to this one. 2.207. And I wrote it down wrong here. 207. 202.133. Okay, so what happens is when we say e to the 10th, that means we're going to move the decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that 10th place I had to add a 0, so I'm going to put 2,207,202,1,330, so 0 there, to the x power. And that is the equation. That's the equation. So it says after 6 drinks, a person weighing 160 pounds will have a BAC of 0.16. And sorry about that. There's extra. It was written twice. How many times more likely is a person with this weight to crash if they drive after having a 6-pack of beer? Round to the nearest hundredth. So what you're going to do is you're going to take this 0.16 and you are going to sub it into here. So you're going to have y equals 0.583 times 2,207,202,1,330 carried to the 0.16 power. Okay, so I just want to show you, now you can go into this calculator. You can go to your y equals, you can put your equation in right there, and then you can go to second table and change it to ask, and then I can put in a 0.16, and when you do, you would get an answer. But I didn't put the equation in because that one was kind of lengthy. But if you were using Desmos, what you could do is, I'm going to add another expression, you could type in x equals 0.16 and check it out. You can see the intersection right here. The answer will be 26.346. And it said rounded nearest hundredth, so that's 26.35. Now, when you're doing the homework, pay attention, okay? Because some of the questions tell you that you can just plug the number in just like I did there. But there are other questions that tell you that you need to round the regression equation first before you plug the number in. And if so, you need to plug it in algebraically like that. So just pay attention on your homework to the directions, okay? All right, so moving on, you guys, and I apologize for how dark this table is, but hopefully you can see it well enough. So pause the video and then put this data into your calculator and then unpause, and we will find the exponential regression, and we will figure out if the spending continues at this rate, what will the graduate credit card debt be 1 year after graduating? Okay, so pause the video, and then when you come back, we will go over the answer. Okay, so we're going to go through this. I put the data in Desmos. Let me turn off these three. All right, I'm going to scroll down to this one. Hold on. This X2 and Y2. Okay, that's where I have this data. And then I'm going to hit the plus sign on the bottom left. Okay, there's that data. And then I'm going to do, now this is X2 and Y2. So I'm going to do Y2 tilde AB carried to the X2 and hit log mode. All right, so it looks like my A is 522.866. Times 1.19645. Carried to the X. And so it says if spending continues at this rate, what will the graduate's credit card debt be 1 year after graduating? So we would take that initial equation that we found, the regression, and instead of X, we're going to put in 1 year after. So how many months is 1 year after? I believe that would be 12. So you would put in 12. So you could type this into your calculators like this, or you could go and add an expression, and you could type in X equals 12. And you might have to scroll over and up. And it looks like 4,499.38. And this is debt, so I'll put it in terms of money. So 4,499.38. Okay, so I went back and double checked. I wrote this down wrong. This should be 886 here. Going back and looking at that equation, it was 886. So sorry about that. Okay, so we are going to stop the video here, and we're going to pick up with part 2 and begin talking about logarithmic regression.